Hey guys, so like I said, I can have you guys look through this activity two, drawing force diagrams, also known as free body diagrams. We're going to be spending some time, a lot of time once we get back looking over this, but this kind of starts to give you an idea of what they are and the process that we're going to have. There will be another video actually walking through drawing them, but right now just understanding a little bit about them and the process that we take in order to draw them out. So a couple of this is review, right? So go ahead and be filling this in your packet while you go through the video. So, all right, this is a force. I'll do caps. How about that? A force is an interaction between two objects that results in a push or pull. This is basically straight from your reading. All right, so you fill that in. So if something is being pushed, something means pulled, some type of force has to be acting on it. Even in terms of gravity, gravity is pulling us towards the center of the earth, even though it's not like a string or a rope or anything pulling. It similarly is an attractive force. All right, so to solve a physics problem involving force, it is nearly always necessary to draw a special diagram called a force diagram or a free body diagram, which we'll describe more what that means here in a second. All right, the first step is often to draw a sketch of what is happening. If it's just a written description, draw a sketch. It takes 2 seconds, but it helps you to visualize what's going on and then where we're actually going to focus on to draw our free body diagram. All right. The second step is to choose your system. All right. System is just a fancy science word to describe what you're focusing on, what you're observing, what you're analyzing. All right. And so you're going to circle the object that is your system, and you're going to do that with a dotted line. All right. So we don't do this step all the time, but it's helpful to be able to recognize. All right. On this scenario, I'm looking at specifically the tire against the the road, not anything that's going on inside the car. Excuse me. So you want to make sure that you would circle that so we know what you're analyzing. That can be helpful. All right. Next, draw the system simply as a particle, which you don't need to. We're not ever going to do that. A circle or dot really is another way, or the way we're going to draw it is a box. All right, there's some reasons why I'm choosing to do it this way. Other classes may use dots. Other courses in other schools may use dots. You may see a dot in a book. You're also going to see boxes, but I think boxes help us to visualize where these interactions are occurring better than a dot does. And so it won't take long to learn how to do that. All right, draw your object or your box separated from its surroundings. So we'll be looking at a car. We circle the tire against the road, and then I would just draw a box, okay, next to it where I'm going to actually draw my forces on it. That's what it's saying. All right, it helps to make the diagram less cluttered. It makes it easier to see what's happening. Is also why this is sometimes called again, free body diagram, because it's all by itself. There's nothing else there, so they call it a free body. It's separate from itself. All right, only forces from objects outside the system that cross the system boundaries to act on the system will be shown on the diagram. Represent all forces by drawing vectors. Vectors also, those are just arrows, right? All right, and then starting to form a system where the force is applied, label all forces by using double subscript notation called the on bind notation. I'll show you what that is. I'm not going to expect you to do that on every single one, but it can be helpful in understanding Newton's third law in particular. All right, we talked a little bit about this already. Forces come in 2 general categories. There's contact and non-contact or ranged forces or range forces. Either way is fine. All right, the 4 types of range forces are gravitational, which is what we're going to be dealing with mostly. All right, electromagnetic, strong nuclear, and weak nuclear force. Again, the nuclear forces we're not going to deal with in this class. Electromagnetic will be in, electrostatics and maybe electric potential and things if we are able to get to those in a similar fashion this year. And gravitational is going to be present all the time. So basically, gravitational is the one that you're going to deal with all the time as well. And so we won't be working with the electromagnetic. Or the forces we won't be working with electromagnetics. The strong nuclear, we're not going to be working with these. Weak nuclear. And again, the electromagnetic, we might get a chance to do that later on. But again, the gravitational force is going to be pretty much every single problem. All right, gravitational force acts between, two objects. And it always attracts, all right? So although it acts on every particle of matter in an object, it's best represented as an arrow from the center of the object, the middle of the object, and it's labeled F sub G, all right? So that's fine. All right, now there are contact forces, all right? There are 4 types of contact forces. We got the normal, friction, and tension, all right? So I just said 4, meant 3, sorry. Whenever 2 surfaces are pressed against each other, that is our normal, that's our definition. All right, this happens because of the tiny level atoms being pressed closely together. I showed you, actually, I may not have shown every single class, that the electrons, the bond length between those atoms are being compressed, and so the repulsion of those atoms is pushing back, and the sum of those is called the normal force. And so times normal forces, all right, and they repel more strongly. That's all it is. All right, then we have a tension force. It's force that opposes sliding of objects. Sorry, just messing up. I'm out of my game here. All right, friction is force that is sliding objects. Sometimes friction can actually move an object along, preventing it from slipping on a surface. So if it might be on an angle and it's not moving, friction actually is keeping it from moving. But we're not going to do angle stuff this unit, this year, so you've lucked out. All right. Yeah, we'll talk about examples in class. Basically, all right, box sliding on ground is one example, and there's 2 types called static and kinetic. We'll talk more about that when we talk about all right, and then last one is tension. All right, always acts along the rope and it always pulls. All right, all that means that if we have something that's hanging, the tension force is in that that rope or that string or that pulley or whatever it is, and it's always pulling. All right, so if it's if you got an object that's hanging to a string, right, the string is always pulling, all right along the string. So even though gravity might be pulling it down, the line is pulling it back up. So that's what that means. So anyway, fill this stuff in. It's nice to kind of sum things up. We talked a little bit about some of these things already, but make sure that you have turned that in and are good to go. All right. Thanks, guys.